reviewing everything that we have learned in Unit 1B. This is just the second half of Unit 1. Alrighty, so this is not going to look exactly like the exam because this is a lot more questions that will be on the exam, but this goes through each topic that we have learned this half of the unit. So first topic we learned was 1.9 and 1.10, which went over all the exponents rules. Product rule, where when you're multiplying variables, you add the exponents. Quotient rule, when you're dividing variables, you subtract the exponents. Power rule, when you have an exponent inside and an exponent outside, you multiply them. The negative rule, where you have to bring it to the opposite side of the fraction to make the exponent positive. Zero exponent law, whenever you have 0 as an exponent, your answer is 1. Or the 1 exponent law, which says whenever you have an exponent of 1, the answer is just itself. All right, so we are going to answer questions 1 through 6 by simplifying the following expressions. Number 1, this is an example of power rule, where you have a variable inside and you have exponents inside and you have the exponents outside. This is power rule. So you're going to give each number on the inside an exponent. This -4 has the imaginary 1 as the exponent, and the 5 has an exponent of 5. You are now going to multiply both those variables by the outside 3. You're basically distributing the 3 to both of those exponents. So you will have -4, 1 times 3 is 3, then b, 5 times 3 is 15. You're multiplying the exponents, the exponent of that current term with the outside exponent, which was 3. Now, the only thing you can do here is -4 to the third. I want you guys to get in the habit of putting this negative in parentheses and then cubing it. So let me go ahead and open up the calculator because that will definitely help us here. So we are doing -4 to the third power. Let's see what that gets us. -4, raise it to the third power. That is -64. And b to the 15 just stays the same. And that is our final answer. That is power rule, where you multiply the exponents. Let's go ahead and look at question 2. Question 2 is quotient rule, where you divide. And when dividing variables, you subtract the exponents. 15 divided by 3 is -5. X to the third divided by x to the fifth would be x. Now you subtract the exponents. 3 minus 5 is -2. And then leave y to the fourth alone, since there is no y at the bottom to divide by. Okay, now problem. You are not allowed to have this negative exponent. So we are going to bring it to the bottom of this fraction. I know you don't see a fraction, but it's imaginarily over 1. So we're going to put x to -2 to the bottom, but make it a +2, and leave y to the fourth on the top. And this would be our final answer. There's nothing more to do since those two variables are not the same. All right, let's go look at number 3. This is an example of product rule because we are multiplying. The mistake here is that, let's just see if we had like x to the x times x to the third. Because these are both x, you would just leave it as x, and then you would add x plus 3, which we don't really know what that is, so we just leave it as x plus 3. If we go back to the actual problem that's here, this says 5 to the x times 5 to the third power. You do not multiply the base. This 5 and this 5 is our base. It's not a coefficient this time. It's not like if we had 5x to the first times 5x squared, where those 5s are our coefficients. When they're the coefficients, we do multiply them. But right here, because these are our actual bases that are being raised to the power, we just leave the 5 alone, and then we add the exponents. X plus 3 is just x plus 3, since we don't know the value of x. All right? That was product rule. Let's look at number 4. This is another example of product rule. Here, because these numbers are in front of the variables, they are coefficients, so we can multiply them. -2 times -8 is 16. Then let's look at the a. A to the fourth times a to the first would be a. 4 plus 1 is 5. Then b to the second times b to the fifth is b. 2 plus 5 is 7. And there is nothing more to do here, so this is our final answer. Now the next two problems that I gave you are multiple choice Regents questions, so we want to make sure we know how to do these. Let's look at answer choice 5. Given the following expressions, which of them are equivalent to x equals -1? All right, let's go work on each one. Number I, that is a product rule. We are multiplying. When multiplying, you keep the base and add the exponents. 2 plus -3 is -1. Number 2, x squared to the -1 power. We are going to multiply these variables. These exponents, I mean. Leave the x alone. 2 times -1 is -2. Okay, let's look at the last one. X, when dividing, you subtract the exponents. 3 minus 4 is -1. And the answer wants to know which ones are equivalent to -1. It would be 1, and it would be 3. So answer choice 3. Now, remember, you would never actually leave your answer as x to -1. We don't like negative exponents. But here they just want to know which one is equal, equivalent equal, to x equals -1, so that is fine. And let's try number 6. This expression is equivalent to, okay, the only time that you add exponents, the only time that this is an example of adding exponents, and you do that when you have the product rule. Remember, product means that you are multiplying something. Okay, so if we're multiplying, it wouldn't be choice 3, it wouldn't be choice 4. Let's see which one it would be. It would be 5a times 5 to the 2b power. But when I look, I don't have that answer. I do have the 5a in both of those, but I don't have 5 squared. Well, let's think about what is 5 squared. 5 squared is 25, and you would leave the b there, which is answer choice 2. And those are 6 examples about the exponent laws. If you are still confused about them, you could watch the video on exponent laws, you could try some of the worksheets, or you could look up problems on exponent laws and try something like that. All right. Now let's go over 1.11, where we were learning about properties of numbers, we were learning about combining like terms, and we were learning about distributive property. For numbers 7 through 10, we are going to start by providing a definition for each of these properties, and then we are going to write an example. Number 7 is commutative property. Commutative property says, when adding or multiplying, you can change the order of an assignment and get same answer. So, commutative property. Commutative property says that when you are adding or when you are multiplying, you can change the order of you could change an order of the numbers You can change an order of the numbers and get the same answer. When adding or multiplying, you can change the order of the numbers and get the same answer. So for example, if you were doing like 1 plus 3, that would get you the same answer as if you were doing 3 plus 1. Or if you were taking some number A and multiplying it by some number B, your answer would be the same as if you were doing B times A. And now let's look at associative property. It says, when three numbers are added or multiplied in same order, that's important, you can change the parentheses and answer will be equal. So associative properties, when you have three numbers that are being added, let's say we had a plus b plus c, that would equal a plus b plus c because those are exactly in the same order, but you are allowed to change where the parentheses are located. So in the first one, I'll put it around a and b and leave c alone. In the second one, I'll put it around b and c and leave a alone. This is associative property because you are changing who is associating with who. All right, two more properties to go over. Now we are going to go over the identity property. The identity property says when adding 0 or multiplying 1, when adding or 0 or multiplying 1, your answer will stay the same. All right, so let's give an example. If you were doing something like 1 plus 0, your answer would still be 1, which means the identity stayed the same. Or if you were doing like a times 1, your answer is still going to be a, so the identity stayed the same. And last one, the inverse property. The inverse property says that the inverse of adding is subtracting, and that would get you 0. Or when multiplying, the inverse is to divide, and that answer would get you 1. So for example, if I was doing 3 and then I put a negative 3, guess what? It's the inverses. 3 and minus 3 are the inverses. Or if you were doing something like 3, in order to get the inverse of that, you would have to multiply by the fraction of 3, which is 1 over 3, and that gets you 1. Those are the different properties of numbers that we have learned about. Now, for 11 through 14, we are going to simplify the following expressions using the distributive property, which that property is when you take the number on the outside and distribute it to both numbers on the inside. And then we might also need to combine like terms if there are. Alrighty, let's look at this problem. We are combining like terms and distributive property, which are two properties that we have learned about. So let's see this. Take the outside 6. 6 times a squared is 6a squared. 6 times negative 4 is negative 24. You are done multiplying by 6 because you are now onto a new parentheses. In front of this next parentheses is a negative 1. Negative 1 times 2a is negative 2a. And negative 1 times negative 3 is positive 3. So now you are done with distributing because you have no more parentheses. We are going to start combining like terms. Our highest exponent is the 2, so I will leave that alone. We then have a plane a, which is the negative 2a. And now let's do negative 24 plus 3. Negative 24 plus 3, and we get negative 21. And this is our final answer. It is in standard form, so we are good to go. All right, let's look at 13. It's exactly what we've been doing, just looks a little bit longer. We are going to multiply this 4 on the outside. 4 times x squared is 4x squared. 4 times 3x. 4 times 3 is 12. Attach the x. And 4 times negative 4 is negative 16. Now for the next one. Negative 2 times x squared is negative 2x squared. And negative 2 times negative 3x is positive 6x. Once you are done distributing, you have to combine like terms. So we have 4x squared minus 2x squared, which is a positive 2x squared. You do not add exponents when you are combining like terms. Now let's look at what is a like term with 12x, this 6x. 12x plus 6x is 18x. And then leave the constant negative 16 alone. That is in standard form because the highest exponent comes first, and then the next exponent, and then the constant. Some questions we could ask you about a polynomial like this is, what is the degree? Remember, degree is the highest exponent, which here is 2. We could also ask you, what is the leading coefficient? That is the number in front of the highest exponent, which here would also be 2. Or we could ask you, what is the constant? Constant is the number without a variable, which is the negative 16. All right. And let's look at 14. Oh, 14 is a beautiful one. The reason why it is beautiful is in front of both of these parentheses is just an imaginary 1. If you multiplied by 1, nothing would change. So all we got to do here is combine like terms. Okay. 3a squared plus 4a squared minus a squared. 3 plus 4 is 7. 7 minus 1 is 6. So we would have 6a squared. Do not add the variables, the exponents. Now, negative ab plus 3ab. There's a negative 1 in front of that. 3 minus 1 is 2. And just bring ab along. And that is our final answer. All right. Now we are going to go over 1.12, which is adding and subtracting polynomials. This is very, very similar to combining like terms and distributive property. Let's look at 15. 15 says, subtract this from this. Whenever you see the word subtract from, you are going to take the second thing and you are going to subtract it from the first. When you write the first thing down, make sure you put it in parentheses or you are going to make a mistake. The word subtracted from, you do the second thing minus the first, but put the first thing in parentheses. Okay. If you put this in parentheses, you could, but there's just going to be an imaginary 1 in the front. It's not going to change anything. So just negative 3x to the third plus 2x squared minus x plus 4. Now in front of that second parentheses, we have this negative 1. Negative 1 times 2x to the third is negative 2x to the third. Negative 1 times negative x squared is positive x squared. And negative 1 times 3 is negative 3. All right. With subtracted from, make sure you put a minus sign and reverse the order. And when you have the second thing minus the first, with the first thing you are going to be distributing the negative 1. And then we combine like terms. Negative 3x to the third minus 2x to the third is negative 5x to the third. Then 2x squared plus 1x squared is 3x squared. Then we'll have a negative 1x. And 4 minus 3 is a positive 1. And that would be our final answer. Make sure you are writing it in standard form because as the direction says, it says express the result as a polynomial, which you did, in standard form. All right. Make sure you are pausing the video and trying 16. Try each of these problems on your own to see if you can get them. All right, so hopefully you tried this problem. This problem says express the sum. The word sum means to add. We are adding the triple of this. If you're tripling something, you're doing 3 times it. So 3b squared plus b minus 4. And you're adding it to 2b squared plus 4. So for this first thing, we're going to have to multiply each term by 3. 3 times 3 is 9b squared. 3 times b is 3b. And 3 times negative 4 is negative 12. And then we're adding it to 2b squared plus 4. There's nothing to multiply by that because there's just a 1 in front and that's not going to change our answer. So let's try this now. We're going to combine like terms. 9b squared plus 2b squared is 11b squared. Leave the 3b alone since there's no other b. And then negative 12 plus 4 is negative 8. And that is our final answer. All right. Now these are two regions questions. Let's look at number 17. If y equals this and z equals this, which polynomial is equivalent to 2y plus z? So 2, then we have to put what y is. Y is 3x to the third plus x squared minus 5 plus whatever z is, x squared minus 12. You could multiply first and then combine like terms, or you could combine and then multiply. I'm going to combine then multiply. This is my only cubed term. Then I have x squared plus x squared, which is 2x squared. And then negative 5 minus 12 is negative 17. Now I'm going to multiply by 2. 2 times 3x to the third is 6x to the third. Do not change the exponent. 2 times 2x squared is 4x squared. And 2 times negative 12 is negative. 2 times negative 17 is negative 34, which is answer choice 1. Very nice. Now let's look at number 18. If c equals this and d equals this, then what is c minus 2d? So first let's put c. C, you don't need to put in parentheses since there's nothing in front of it. We could just put 2a squared minus 5. Then it says minus 2. And now they want us to put d. I'm not just going to put 3 minus 1, because then it looks like I'm writing 23. I have to put this d in parentheses. Leave 2a squared minus 5 alone. And now let's distribute this negative 2. Negative 2 times 3 is negative 6. And negative 2 times negative a is positive 2a. Okay, we're going to leave the 2a squared alone. Bring over the 2a. And negative 5 minus 6 is negative 11, which is answer choice 3. All right. Now we are going to move on to multiplying polynomials for the next 4 questions. So let's look at this first one. We are going to multiply 1/4 b times 16b. 1/4 times 16 is 4. And b times b is b1, and b1, you add the exponents, that gives us b squared. Then 1/4 b times negative 12b squared. 1/4 times negative 12 is negative 3. b1 times b2 is b3. And then 1/4 b times negative 4 is negative 1b. You don't change the b because there's no b in this term. There's only this original b. You cannot just submit this answer. You have to write it in standard form, which right now it is not in standard form because this is the highest exponent, the 3. So you have to write that term first, but make sure you write negative 3b to the third. Then bring your positive 4b squared and your negative 1b. Which if this was multiple choice, they wouldn't even write the 1, they would just write b. You're not wrong if you write the 1, they just wouldn't do that. This is this in standard form. Now let's look at number 20. Ooh, this. 4b minus 2 squared, meaning you have to write that 2 times. And then the final answer that you get, you're going to subtract 1/2 b. So let's look at it. 4b times 4b is 16b squared. 4b times negative 2 is negative 8b. Negative 2 times 4b is negative 8b. And negative 2 times negative 2 is positive 4. And then we're going to bring down our negative 1/2 b. Okay, let's combine like terms. 16b squared. We have negative b minus b, which is negative 16b. Oh, I forgot about the negative 1/2 b. Let's see what that is. Negative 8 minus 1/2 is negative 16.5, or negative, what would that be as a fraction? Because the calculator at our school would give you a fraction. That would be negative 33/2. Let me just make sure. You could write negative 16.5. I just know the calculator at our school will give us negative 33 over 2. And then bring down the constant, which is plus 4. All I did was when you see 4b minus 2 squared, that means you write it twice. I multiplied it out by multiplying each term in the first parenthesis by each term in the second parenthesis. And then I brought down the minus 1/2 b, and I combined it. All right, let's look at 21. Express this in standard form. Let's start by just doing this part. 4x times x is 4x squared. Then we have to do 4x times 6, which is 24x. We are now done with the 4x. Then negative 2 times x is negative 2x. And negative 2 times 6 is negative 12. And then we're just bringing down the minus 1/4 x squared. Now let's combine like terms. 4 minus 1/4. 4 minus 1 over 4 gives us 15 over 4 x squared. Then 24x minus 2x is 22x, and the minus 12. And this is our final answer. And let's look at 22. Express the product in standard form. Product means to multiply. So we are doing 2x squared plus 7x minus 10 times x plus 5. All right, let's try it. 2x squared times x is 2x squared plus x1 is x to the third. 2x squared times 5 is 10x squared. Now let's do 7x times x is 7x squared. 7x times 5 is 35x. And then negative 10 times x is negative 10x. And negative 10 times 5 is negative 50. And now we could combine like terms. Leave the 2x to the third alone. Then we have 10x squared plus 7x squared, which is 17x squared. Then 35x minus 10x is 25x. And bring down the minus 50. And that is our final polynomial in standard form. And now we are going to go over dividing polynomials. Let's look at this first one. Remember, when dividing, we subtract the exponents. So we are doing negative 12a to the third divided by negative 8a. Negative 12 divided by negative 8 gets us 3 over 2. That is okay. Then a. a3 minus a1 would just leave us with a2. Now we are going to do negative 8a times negative 8a. Negative 8 times negative 8 is a positive 1, so plus 1. And a1 divided by a1, 1 minus 1 is 0, so we would have nothing left. Now let's look at 24. 16y to the third divided by 8y to the fourth. 16 divided by 8 is 2, then y. 3 minus 4 is negative 1. Okay? Then negative 8y to the 6th divided by 8y to the fourth. Negative 8 divided by 8 is negative 1. Then y, 6 minus 4 is 2. Problem. You are not allowed to have this negative exponent. You will leave the 2 on top, put the y to the bottom and make it a positive 1. And you could leave this next term alone because there is no mistakes with it. That is perfect. All right, let's look at 25. All right, 25. We are going to do this divided by this. 27 divided by 9 is 3. Leave the k to the fifth alone since that's the only k we're working with. M to the 8th divided by m squared would be m. 8 minus 2 is 6. And now let's look at this next one. Negative 18 divided by 9 is negative 2. We have m to the 1 divided by m to the 2. 1 minus 2 is negative 1. The first term is no problem. But the second term, we have this negative 1 as an exponent, which means we actually have to bring this to the bottom. and put it over m to the positive 1. And this right here would be our final answer. And let's look at this question. This is a polynomial being divided by a monomial. 15x to the third divided by 5x squared. 15 divided by 5 is 3. X to the third divided by x squared, you subtract 3 minus 2, which gives us 1. Then negative 5x squared divided by 5x squared. Negative 5 divided by 5 is negative 1. X squared divided by x squared would leave us with nothing. And then 30x divided by 5x squared. 30 divided by 5 is positive 6. X divided by x squared would be x, but now we have 1 minus 2, which is negative 1. Remember, you cannot have this negative, so we are going to bring it to the bottom. Put the 3x to the first. Then this has an x, so let's bring it next. Plus 6. Don't leave the x to the negative 1 on top. Bring it to the bottom. And then put our constant negative 1. The negative 1 stays on top because it doesn't have a negative exponent. It's just that the number itself is negative. Right, good. And let's look at these last 4 questions where we are going to translate these expressions into algebraic expressions. 27. Andy has this much money in his account. Each week he withdraws this much. Ooh, when you withdraw, you're taking away, so there should be a minus in our problem. Okay, which expression can be used if he wanted to find out how much money he had left after 8 weeks? Okay, so we started out with $310, and he's taking away $30 every week. So we're subtracting 30, and he's taking it away every week. So Andy has $310 in his account. Each week, he withdraws $30 for his expenses. Which expression can be used if he wanted to find out how much money he had after 8 weeks? So we don't have any problem here that says 310 minus 30 weeks. Okay, I can't choose choice 1 because that's saying minus 8 weeks. We know that it's 8 weeks, but we need to somehow have the 30 for every week. So it can't be choice 1. It's not going to be choice 2 because that says I'm doing 310 time weeks. No, that's not good. Now, the difference between 2 and 4. With 2 and 4, how they got 280 is they already took away one of the weeks. 310 minus 30. They already took away one of the weeks, and that's how they got 280. Every week after that, he's going to continue taking away money, which is choice 4. And why it says week minus 1 is this 280 is already taking away minus 1 week. So when we do the weeks, we need to already take away one of those weeks. All right, let's look at 28. To watch a varsity game, spectators must buy a ticket at the door. The cost of an adult ticket is $3. So it's $3 per adult. Student tickets are $1.50. $1.50 for students. Okay? It then says, if the number of adult tickets sold is represented by A and student tickets is represented by S, which expression can represent the amount of money collected at the door? Well, how many adults and how many students they have, they're going to add together, which is choice 4. All right, let's look at 29. Which verb expression is represented by this? 1/2. Okay, I know I need to have a 1/2 in there, which all of these say 1/2. 1/2. And then it says n minus 3, which is going to be n subtracted from 3. Well, if we have n subtracted from 3, that means you would reverse the order and do 3 minus n, so 2 is not going to be correct. N decreased by 3, that might be good. The difference of n and 3, the difference of 1/2 n minus 3. Okay, this is what you guys need to realize. This is 1/2 of this whole thing. It's not just 1/2 of n, because it's also 1/2 of negative 3. You know how you would distribute this 1/2 to both? So choice 1 says 1/2 of n. It's not only 1/2 of n. It's 1/2 of the n and 1/2 of the negative 3. So 1's not going to be good. 2 says the difference of 1/2 n and 3. That's not good because now you're only doing 1/2 of n. You also need to do 1/2 of 3. But 4 is saying 1/2 of the difference of n and 3. So this is saying 1/2, then the difference of n and 3. Choice 4 is good. And let's look at 30. 30 says, which variable expression is represented by 2x plus 4? This is again where I need you guys to know that it's not just 2x. It's 2x and 2 times 4. Choice 1, twice the sum of n and 4. That might be good. Twice means times by 2. Then you're twicing the sum of n and 4. That might be good. 2, the sum of 2 times a number and 4. You're not only doing 2 times a number, you're also doing 2 times 4. So that's no good. Choice 3 says the difference. Nah, there's no subtraction here. And choice 4 says twice the product of a number and 4. Twice the product of a number and 4. Product means you would be multiplying a number and 4. We're not multiplying a number and 4. 4 is no good. So our answer is choice 1. And that wraps up all the different topics that we have learned in Unit 1B. Make sure if you are confused on one of the topics, you go back and watch one of those videos or look for more example problems on it to continue practicing.